and we're done. We can't find an inverse function if the function's not 1-to-1. So let's do what type of function is that? Yeah, it's a linear function because the denominator doesn't have a variable in it, right? We could think of it as like 4/7 x plus 3/7, like if we divided each term by 7, right? So this one's actually just a straight line, and all lines are 1-to-1 except for horizontal lines. So that'd be a pretty boring function for me to give you as a constant function. But so all linear functions are going to be 1-to-1, so we can go ahead and find the inverse. So we have y equals 4x plus 3 over 7. I'm going to clear fractions. So 7y equals 4x plus 3. Subtract 3. And divide by 4. So f inverse of x multiplies its input by 7, subtracts 3, and divides by 4.
Quick question.
Yeah.
So for A, can we really not find a graph that just is the opposite?
We can find a graph, but we can't find an inverse function because its inverse is not a function. So if we, like the graph of this looks like kind of like, it was kind of weird, but look like kind of like that. And so its inverse would look like this. So it's not that it doesn't have an inverse, it doesn't have an inverse function. So we can't find something in function notation, like we can't find an equation for the function. We can draw a graph of the inverse, but because it's not a function, we can't write an equation for it.
So, but that equation on the right has a function, or that graph on the right, the pink line, has a function.
It has an equation.
Or an equation.
The equation is not a function.
Got it. Okay.
So the equations like this have like x squareds and y squareds in them.
Okay.
So if you, I mean, it's subtraction, or else it'd be a circle. But they're like something like this. And if you tried to solve that for y, you would get a plus or minus, which that's what gives us this and this.
Right.
But it's not a function. So if you can't solve it for y, you can't write it in function notation. So it's this word right here that makes us stop when it's not 1-to-1. Okay, you guys do this one. F of x equals 3 over 2x minus 1. So as far as this being 1-to-1, I'll just tell you that it is. And a good general rule about rational functions is that if the numerator and denominator are linear, then it's a 1-to-1 function. So if there's no exponents on the variable in the numerator or denominator, then it'll be 1-to-1. Y equals 3 over 2x minus 1. And then we multiplied by 2x minus 1, which canceled it on the right side. And so at this point, if you divide by y, there's nothing wrong with that, but you will end up with a complex fraction as your final answer, and we never want complex fractions as our final answer. And so you would have to simplify that, which is just kind of a pain. So to avoid that, we'll distribute. And then I want to get x by itself, so I need to add y to both sides. And then you can divide by everything that's being multiplied by x all at once. So we'll just divide by 2y. So even though the 2 and the y aren't like next to each other on the left side, we can still divide by both of them. So we get x equals 3 plus y divided by 2y. And so f inverse of x equals 3 plus x over 2x. Any questions on that one? Okay, what are we on? D? So let's do f of x equals x over x plus 5. You guys want to try it or you want me to do it? You want me to do it? What'd you say?
I'll do it.
Oh, Colton's going to do it for us.
Oh, am I?
No. You guys can all try it. Just remember that you need to solve for x, you need to get all the terms that contain x on the same side. We had y equals x over x plus 5. And just like the last one, we're going to multiply by x plus 5. And then distribute. And then we want to get all the terms containing x on the same side. So we're going to subtract xy from both sides. And then we had to factor out that x. So we get 5y equals x times 1 minus y. And then we get to divide. So this one's a little bit trickier, but really it's just like these two steps that make it different from the last one we did, right? Was just that we had 2 terms containing x instead of 1. So then remember to write it in function notation. We have 5x over 1 minus x. And let me give you your worksheet before you go.